Hey, what's going on, guys? Komeki here. Last video we ended up with a boilerplate code to initialize the segment registers, and we also created a procedure to print the string to the screen, basically in real mode when the computer just boots. But the very gist of the bootloader itself is to load some executable file from the storage device to the to the random access memory and jump there to that address and run that code. So bear in mind the fact that we're supposed to be writing what are we writing here? So we're writing what I'm calling GameOS. So this is going to be a simple executable that would be allowing us to run boot sector games. So in order to run a boot sector game, we'll need to read that from the storage, put it to the boot sector, jump there and execute the code, and then we'll need to jump back to the shell. So I was thinking to make a menu first, but then I decided that it would be better to make a shell, because in case of a menu we're limited with only those number of entries that fit the width and height of the screen. However, if there would be more one day, using shell is more appropriate to match like whatever whatever game is available on the storage device, we can load that. So I'm not going to be implementing the file system, obviously, that would be too much, but some rudimentary file system like, I don't know, layout is still needed, because we need to know which we need to know the address of every single game that we will be kind of like extracting from the storage device, from the USB flash drive in our case. And I will make that simple. I will go the that simple way. So it would be like a list of names, and every item would be associated with a single sector on a flash drive, right? So like the first sector is a boot sector, the second sector would be holding the file names, the third one would be holding the shell, and then starting from the fourth one there would be like game 1, game 2, etc. So it's incredibly important to visualize whatever you're doing first, so before writing whatever code and before getting into how we can actually read from the physical device. Let's populate our random access memory map and the floppy image map as well, to get it crystal clear of how exactly our memory is aligned. So again, so this is not really that much about the coding itself, but it's more like understanding where exactly the memory is used and how exactly. So okay, so here, so if so just a little trick. So how do I calculate all of these values? So we just copy this one and go to the calculator and paste. We're in hexadecimal mode. I say +1 and equals. So this is the starting point of the next 512 byte chunk. Okay, so here I can say place this one. So this is the starting point, and now we need to add a 512 bytes. So in hexadecimal this is gonna be 200s, but I just want to show you how this is really true. So go back to decimal. 512 in hexadecimal, this is 200. So we need to say 7E00 plus 200s. Okay, and this is the value that we have. So we just copy this value and say 0 and put it here. So within this range, we would be having our, well, let's call it file system, but it's not really file system, but the list of games, a list of apps. I don't know. So yeah, let's call it game list. So it's would be 512 bytes. And here we say the game list. Well, probably if we come up with somewhat a different kind of like application of the game, but maybe, I don't know, some basic interpreter like Oscar Toledo has written once and things like that. It's not obviously, it shouldn't be the game obviously, but I just call it like a game list here. So now another little thing to consider. So we also need to define the place of where exactly we're gonna be running our, shell. So the shell is the application to, like, it would be text based, so we would be able to type the text and to delete the text and hit enter, and if we hit enter we will need to match whether the game is available or not, and if it is in that case we'll need to load that game to another certain specific place, to the boot sector, by the way. So yeah, okay, so now let's say but okay, as far as we're not dealing with a shell at the moment, probably this is enough, so let's just leave it as is, and instead let's go for, so I need to say, oh man, so 0 1 f plus 1, and we have 200s, okay, which is logical. Yeah, 512 bytes, so from 200s and up to plus another 200s, so 400s. Yeah, this is really what it should be. Okay, so within this range, so here we're already dealing with what I call the floppy image map. Again, like we're going to be writing this floppy image to the USB flash drive, but I still call it floppy image because of the overall size, which is equal to floppy image, and it's just easier for me to think about this as if this was a floppy image. So I've been trying to explain this in the first part, in the previous part, and this is going to be 512 bytes as well. Okay, so here again, like we have our game list. So this is the location of the game list on the floppy image, and this is the memory address where we're supposed to be loading our game list when it comes to writing it to memory. Okay, so I hope it's clear. Okay, and then when it comes to shell, it would be, yeah, okay, doesn't matter. So I'm sorry, just thinking, I was trying some experiments, but doesn't matter. Okay guys, so the next extremely important thing to consider, so once we have dealt kind of like with this, so where the game list would be, before actually creating a file for that, there would be a separate file. We could have write this within the bootloader or on its own, right? Like down below here. But I just really want to keep things simple, clear, and didactic. So for that purpose, I would better make a separate file for that. Okay, so I just wanted to give you a bit of an idea of, or maybe I'm just wondering where to start, where would it be better to start either. So we're done with the memory map. Okay, so yeah, let's first create this game list. So let's create a data for a second sector, all right, and then we just go for the implementation. So yeah, I just want to create a new file. So create new file. Let's call it a gamelist.asm. Okay, and I still want to. So yeah, still. I'm not sure whether it's a good idea, whether this line is actually needed or not. I'm not really sure. Okay. By the way, here's a little mistake, guys. This should be bytes, not the words. Okay. Or hold on a sec. Yeah, it should be bytes here. Yeah, I'm not sure whether this is needed actually, but let's keep it. And also we will need to fill the rest with the zeros, just like we did in the first part. Maybe it's not the best ever way of doing things, but anyway. And here we can just provide our data. So we would be using, I don't even need to label that, right? So just the pure DB, okay, and like this. So here I just provide the debugging message. So let's say hello from sector 2. Here are the games available, okay, and then let's say define byte, and let's say Tetris, okay, 0, let's say I don't know, bricks. There is a nice game by Oscar Toledo. I don't know, define byte. I don't remember which one I was testing. The one named slides. So slides, okay. And don't forget the 0 terminating character. Okay. Yeah, let's just make it like this. So this is the dummy string. We'll get rid of this later on. So dummy string here. Let's say label for Tetris here. Well, okay, guys. Probably we don't need to be that specific here. We just can say generally that here we want to. Here we have the list of available games. All right. Okay, and now let's also open our run shell. Okay, F9. So assemble bootloader, and then we want to assemble gamelist. So here I'm doing the same, but like so. Okay, so I think we can run it now. I'm not doing with a game list anything at the moment, but so operating system is loaded. That's the message from the previous part. And now what I want to have a look at is how this, oh, hold on a sec, I just did a bit wrong thing. So it's called a game list, and this is gonna be the game list.bin. Well, maybe we can call it file list. Yeah, let's call it let's just call it files, because it not obviously would be games. So let's call it files. Here let's call this rename. Let's call it files as well. Files, okay, and in the memory map F9, and in the memory map just call it files and files. All right, so run shell files bin, okay, run again, all right, and xxd files.bin. So the hexadecimal representation, okay, bricks, yeah. So we have the list of our games separated by zeros, okay, zero terminating character, and that's exactly what we want to have. So it's very efficient from the perspective of from the density perspective, let's say. Okay, so now we need to add this files as the second sector to our flash image to the GameOS image. So it would be the second one. And how can we do this? This is very simple. Yeah, also we need to remove it, by the way, later on. So remove files.bin. Okay, it's better to call it file list, but let's just keep it like files, available files, like the shortcuts for files. Yeah, we can just spend ages on guessing the better name for a file name. Okay, so cat here. So here we want to add files.bin, but there is an important point. So here we had subtracted one sector for bootloader. Now we need to subtract two sectors for bootloader, one for bootloader and another one for this files. So for, let's say, -2 sectors for boot, and it would be like this. Okay, so like this for bootloader and files. Okay, and yeah, so can we recompile it? Yeah, let's run. Okay, it's loaded, good. And I want to inspect how xxd GameOS image, or how is that called? Yeah, GameOS image. So xxd gameos.image. Okay, so what we have now, so the first sector on a floppy drive is the bootloader and ends up with a boot signature, and now we have the second sector, right? So it doesn't end with a boot signature because we don't need that really, but this is another sector that we're going to be actually loading to from the floppy image, from the USB flash drive physical memory to the random access memory. Okay, so and then we'll just print this. Okay, we're not going to be jumping here because no code here, just a text. So the third sector would be occupied by the shell, and in that case we're going to be jumping there to like execute the shell. But for now, okay, so I hope it's clear. Okay, so now what do we do? What do we need to do now? Now we need to write code to load a single sector from the floppy drive. So I just want to say that whatever we have with it. So the first sector, here is the deal. The first sector, the boot sector, is loaded by BIOS automatically. So we didn't need to do this, right? But the second sector, this one, it's not going to be loaded automatically. We need to do this manually. And in order to understand how exactly the certain register is being initialized, we need to have a look at how this, I'm not sure whether this is probably the hard disk drive, the HDD, because we have the multiple disks. So we're going to be initializing what is known as cylinder and what is known as head. So if you want to have an extended understanding of what those are, you better read this excellent Wikipedia article. From my side, I can say that so this red guy is the sector of up to 512 bytes that we're going to be reading. Okay, and we'll set cylinder and head equal to 0. I'm not yet sure whether this is going to be working with only like the first like, I don't know, is it going to be working in all the cases or not? So I didn't yet learn that deep enough, but just to give you an idea that the cylinder is this blue thing and here is the head. So the cylinder is and head are some actual physical kind of like parts of the hard drive. However, there is no such thing in the flash drive, right? But the way of initializing the registers probably due to the reasons of the backward compatibility, are still involving setting up cylinder and the head. Now let's go to the documentation on BIOS interrupts, and here we have interrupt 13H, and if we want to read disk into the random access memory, we need to set up the AH register to this value. So remember, like AH is there is the AX register in 16 bit mode. In 32-bit mode, this would be EAX, and AH is the 8-bit register. Like the AH stands for high, so this is the higher part of the 8 register. We also have the low. It's used here. So we need to specify number of sectors we want to read, the cylinder, sector, which sector in particular we're gonna be, we want to read. In our case, this is the sector number 2, it's fixed, okay? Then the head number would be equal to 0, and we're not gonna be using this one. In our case, it's just not needed to make it work. I figure out that via the trial and error method, so don't ask me why. That's the only way how it works, not only on emulator, but on my real hardware as well. So yeah, and yeah, I believe at the end of this video, I will make a quick recap on how this works in the real hardware, because it's absolutely essential. I had some experience earlier, like about 2 years ago, but I did manage to read from flash, but I didn't ever manage to write to the flash USB flash drive, and that was not really fantastic, and that was one of the main reasons why I've dropped this low-level programming. But now, when I finally dive deep enough to understand how this works, lots of new opportunities are getting available. Okay, so now when we know what the head and what the cylinder is, I don't know as well, but just to give you an idea, now we can actually go and start writing some code. Okay, so we're gonna create a new procedure, and I will make this. So, well, first of all, let's specify another message. So let's specify the error message that would be firing in case if it fails to read data from the sector. Sorry, so error message and db defined byte 0 terminated character. So let's say failed to read sector, and well, sector 2 in particular, because we're going to be reading well, that's not specified because we would also be reading the shell, so let's not specify which sector in particular. So failed to read sector from HDD, because we assume this is HDD or USB, let's say from USB. Okay, because it's only intended to run from the USB flash. Probably it's possible to write this to the real hard drive, but I wouldn't be doing this. Okay, because it just won't be working any longer because of this raw file system. It's not even a file system. Okay, anyway, so print string, and here I want to create a procedure to read a single sector from USB flash drive. And remember that the USB flash drive is treated to be like an HDD drive, like a hard disk drive from the BIOS perspective. Okay, so the very first thing to do here, well, let's actually call it, so read sector. So I'm creating a label here, and now let's go step by step. So I need to say move to CL, I want to move to. So here I specify which sector to read from USB flash. Okay. Did I mention floppy here? Nope, I didn't. Yeah, that's good. So which sector to read from USB flash? This is it. Then move to AL, move 1, and here we specify how many sectors do we want to read. So how many sectors to read, and we're going to be reading only one sector. And by the way, one of the I forget the word. Well, one thing that stands out in regards to this GameOS that we're developing is that whatever application we're going to be running would be the size load is only 512 bytes, because only in that case that application might not only be running under this operating system, but it would be able to run like independently as the boot sector program, as the bootloader basically. So that's the idea, to be free forever, so the operating system is not forcing you to do anything. By the way, the only restriction would be that I will need to specify some specific places. So this memory, random access memory layout. So if you would be writing boot sector game, I would be asking developers not touching certain range of addresses. It's probably no more than 1 kilobytes. So one for this file system and another for the shell itself, and all the rest of the memory is free to use, including where exactly you will to specify the stack. And by the way, I'm not specifying the stack because boot sector games in most cases do specify the stack explicitly. So I'm not doing this because I don't know how to do it or something, but just because to give a freedom. Because let's say if I specify the stack, let's say from 7C00 and goes like below, like to the last number, to the last number. In that case, it might not be that great because your boot sector game may be relying on that sector for some reason. So that's the reason why I'm not specifying the stack. And as far as the shell is not doing push or pop operations, we don't really need the stack. So there is no need to specify that. So it's just not because I can't do it, but just for the reasons of being free. So the game itself would be setting the stack where it wants to. So the only, again, like restriction just not to set that to a certain range of addresses, which would be incredibly small. So general operating system and trying to occupy everything and rule there, setting up their own rules, and then developers have a very limited kind of like space where they can be free, where they can do something. So the idea of GameOS is completely opposite. So we want to operating system to be something little somewhere here, and the boot sector game can do whatever you want. So developers are absolutely free to do whatever they want, however they want, and still this is intended to be possible to get run via the shell of this game as they were developing. Okay. So the next thing, now we need to initialize the cylinder and head that I've been talking about. So move ch0 and move dh0 as well. So here we specify cylinder, and here specify head. I hope I've spelled the specify word properly. I'm sorry guys, just let me very quickly check my pronunciation, because yeah, I'm not a native speaker and I really don't want to. Oh man, what have I just done? Okay, specify. Yeah, all right, so head and cylinder, and this is pretty it. So now we need to call the int hexadecimal 13 interrupt to actually read the sector from USB drive. Okay, USB flash drive. So this is the BIOS interrupt I've been talking about. So we have the documentation here. So int13h. This is what we're using here. All right. Okay, and also we need to, well, it's not obvious, and I know it's gonna be working, but it's also a good idea to make a little error handler. So from the documentation, we know that the so-called carry flag if you don't know what the carry flag is, there is good reference here on the registers. So carry flag, okay, so what it is, how it works. So as the side effect, I would say, yeah, the carry flag is set to 0, so it may be either 1 or 0, hence the flag name, the name of the flag. So it's set to 0 in case if this operation fails to load the data. And there is a instruction for processor JC, which means jump on carry flag. So JC, and I want to jump to, let's call it just error. So if failed to read the sector, let's say go to error handling. Let's say do error handling, let's say handle the error. And here I want to specify this error as the label. Here I want to initialize my SI, source index, with this error message. Okay, and then I want to call print string. All right, and I want to go to the infinite loop here, so literally, so jump here. What I've just written means jump here, because if we fail to load the sector, there is no reason for further loading of anything, because we just can't read the storage device properly, so it's not going to be working anyway. So we want to print the message and then nothing happens. Okay, so here point, where is this, copy, this is it, point source index register to error message string address. Here we want to print error message. Okay, and this is known as processor trap and so on. So let's say like, well, literally this is the infinite loop. Let's just say stuck here forever. Okay, stuck here forever. So hopefully we're not going to be getting here at all, but just for clarity, I've provided this sort of a thing here. Okay, so now how do we know? Well, we know that if this error message doesn't occur, that means that everything is okay, but we also want to check whether the data has been actually uploaded correctly. So the data that with this false, we want to print this. And oh, okay guys, sorry, just forgot another absolutely essential thing. So here we actually need to do the following thing. So we need to say move bx, and now the address of where we're supposed to be loading our data. So let's go back to my memory map, and here is the address. So copy, and I want to load it here. All right, so this is known as the destination address of where data from sector 2 is going to be loaded. Address in RAM is going to be loaded. Okay, and also, yeah, hold on a sec. Yeah, I just It doesn't matter really, but I just want guys, because as far as we're going to be reusing this potentially later on, I want to put this, the initialization of which sector in particular here, because this serves these two guys might be treated as the arguments if we're thinking from the high level programming language perspective. So we specify the destination where to load and also which sector. So it doesn't matter, would it be working if it was a year as well, but I just want to pick it. I just want to keep it a year. And finally, we need to call our read sector. So call read sector, and actually read sector from USB flash drive. Okay, so I just need to figure out, yeah, I forgot to put the return statement here. So yeah, all right. Yeah, so we jump in only if carry flag is equal to true, otherwise we want to return, right? Okay, so return from procedure. Okay, save, right, return from procedure. Okay, yeah. And yeah, and one last thing. So once we've, well, let's actually try to run this first. Let's try to run this. I just want to make sure that we're doing everything. So assembling the bootloader, assembling the files, specifying, yeah, the proper size of the floppy image, concatenating the boot, the files, the floppy bin to this, deleting all the stuff, and yeah, it should be working. Okay, I'm a bit confused by the fact that it's no longer printing the message. Hold on a sec. Let's just, as far as we're not jumping anywhere, we need to add this infinite loop here. Okay guys, just hold on a sec. Okay, so I've missed the error. So an error at line 15. Yeah, obviously we need to make it in the hexadecimal mode. And yeah, so boot sector. So okay, GameOS is loaded. Oh, did it really fail to boot it? Come on. Well, at the very least, we've seen that this is working. I didn't manage to do so when I was. Oh no, it's not the error. I believe that I either missed. Well, okay. So first of all, here I want to make a new line and the carriage return. Okay, and here I want to give a new line and the carriage return as well. Save. And run. Yeah, for some reason it fails to load from the USB. I'm just wondering whether it really fails to load from USB or whether it just prints, unintentionally prints the message that goes just right after it. So if I just get rid of this part, I will know for sure. Yeah, probably this was the error. Okay guys, give me a minute to figure out what's going on here. Okay, it seems like I just forgot to initialize the AH register to specify the code for reading. Okay, so let's do it here. So move AH hexadecimal 2. And this is the BIOS code to read from storage device. We're not specifying which in particular because it's the same no matter what, from what storage device do we do we read the data from? Okay, let's try again. Okay, so did I restore? Okay, maybe we just doesn't seem to. Well, now it doesn't print. Now it doesn't print the error, which is good, which probably means that it has been successfully done. Oh yeah, so we didn't yet actually bring that data. So yeah, we need to say move si, and now whatever is available. Hold on a sec, guys. Sorry, I just specified the address in a wrong way. I should have been doing this like so. Copy and call print. So here we point source index to file list, okay, where we just loaded it, and here print file list. We'll get rid of this later on, it's just needed for debugging, but still how this makes sense. And this is the infinite loop, so just a placeholder, okay. And this is strange, for some reason it's not working. Okay, guys, I'm sorry, just made a couple of mistakes. So it seems like I've created a label instead of calling the print string. And another, by the way, let's see, let's have a look at it. Yeah, it's already good enough to work, but there is another minor error here. So we see, like, we make the second sector to be like, we put the boot signature on a second sector. We obviously don't need to do this, and we need to say like this, so 512 minus whatever we have there, okay. And we now run, we have this hello from boot sector 2. And now the reason why it doesn't print the rest of the data is because of the trailing zero of this zero terminating characters. So let's say we get rid from 1, and let's say we make something like new line in the carriage return. It would print already 2. It would already print 2 lines for us, but it's not really intended for that purpose. It's just the storage. And the proof of concept that we want to figure out is it actually does load the data from this second sector to the specific address in the RAM memory, to this one in particular. So here, okay, so here we load, and then we read from here, okay, and then we print. That's pretty it. So here I just put it back to 0, and the final run, so hello from sector 2, which means that the sector 2 has been successfully loaded. Okay guys, so this is it from my side. I believe that starting from the next tutorial we're going to be implementing our shell, which would be living in the sector 3 on the storage image, right, on the USB flash drive, and it would be loaded to, I'm not sure where exactly, probably to the next 512 bytes, just right after this list of files. I think that would be just fine. So yeah, this is it from my side. Thanks for watching. Until the next time, and take care. No, I'm sorry guys, I forgot one incredibly important thing. So we need to test this on the real hardware, and yeah, I will now do this basically. So Yeah, this is incredibly important because it sometimes might work in the emulator, but might not be working on the real hardware. So it's incredibly important to test this on the real hardware. Okay, so I just want to clear and say xxd gameOS.image. All right, so we have a bootloader and we have the data from the second sector and no boot signature here. Great. So now we're going to be writing this to the USB flash drive. So here we go. So I want to say sudo f disk -l. I don't have my USB drive being plugged in yet, so I do plug it in and run the command again. Okay, run again, and now here it is. It's dev as db, and now I'm going to be using the dd command to write this image that I've just created to the flash drive. So I want to say dd, and the input file equals to gameOS.image, and then the output file would be equal to dev as db, where my flash is. Now the count is 2880, so I want to write all the sectors we have. So remember, we have initially 2880 sectors, and the byte size is going to be equal to 512. Not the byte size, but the bytes, 512 bytes. Okay, and here we go. What? Oh, sorry. Should be equal sign here. Permission denied. Okay, sudo obviously. Okay, here we go. And now let's clear and let's say xxd. Nope. Sudo xxd and dev as db. Yeah, and now we should. Now I want to make sure that on the USB flash drive I have the bootloader first. Then I have the boot signature, and then I have the data that we're going to be uploading, like reading to the RAM, and then we're going to be printing that memory from the RAM. Okay, so I can now unplug my flash drive. Okay, so here is my flash, and I pause the recording here on my laptop and take my wife's smartphone, and would show you how this is going to be working on the real software. So stay tuned. Okay guys, so here is the flash drive that we've just prepared for loading our operating system. So just plug it in. Okay, and the moment of truth. So I'm starting my laptop. I already have the BIOS being configured. This has been shown in the previous video. And now we should see the greeting message. Yeah, and here we go. And also, now we know for sure that the second number 2 on the floppy image that has been reading to our USB flash drive has been successfully, oh man, what's wrong with the camera? Has been successfully loaded into the random access memory at a certain address. So that's that's what we wanted to prove, basically, that not only in the emulator but on the real hardware it's kind of working. So now this is really it from my side, guys. So thanks for watching, and I'm not gonna be, it's a bit of a pain for me to set up this camera and to shoot the laptop, but I just really want you to feel it real, right? And for the next few videos, I'm not going to be doing this, but once I'll have something really interesting to show you, like the list on games being able to play in this sort of a manner, I just spent, I'll go extra mile to set up the camera properly and make a full-blown episode on how I work on the real hardware with this operating system we're developing. So this is it from my side, and thanks for watching. Until the next time, and take care.